Effects of electromagnetic interference and radio frequency interference on metal detectors. Sources of EMI and RFI include electric motor drives, such as variable frequency drives and servo motors, two-way radios and walkie-talkies, electrical loops, electrical contacts and contactors, and static discharge. Implications for metal detectors include false detections or false rejections, and reduced performance. For this demonstration, we will be using our Big Bag King metal detector system, shown here detecting a 2 mm stainless steel test sample in the center of the aperture at a signal of approximately 200. To generate noise, we are using a typical VFD that is running an AC motor in close proximity to the metal detector. Inside the control box is the VFD, which is connected to power through an RFI or EMI line filter, which prevents noise from transmitting through and from the incoming power bus. The cable to the motor in this case is the weak point of the setup. VFD cabling is not utilized, so there is no shield on the cable and it can radiate EMI. We will now close the box and start the motor. Notice that the strength of the signal generated on the metal detector gets larger as the source moves closer and is more visible to the coils. The EMI is broadcast over the air and into the receiving coils of the metal detector. The worst case is when the aperture opening is in line with our noise generator, as there is a clear line of sight between the motor cable and the metal detector coils. When the source is positioned to the side, the aluminum case of the metal detector helps to shield the coils. We can see the noise using a pickup coil hooked up to an oscilloscope. First, we will put the pickup coil into the metal detector. The waveform shows the operating frequency of the metal detector and the signal it is broadcasting from and receiving between its transmitting and receiving coil. Now bringing the pickup coil close to the motor cable will show the EMI that it is emitting. The best way to fix the noise is to eliminate it at the source. In this case, the motor cable should be replaced with a shielded VFD cable with a shield or screen correctly terminated to the ground. This will block the noise from leaving the cable. However, we have some tricks to get around noisy environments. We have applied noise reduction hardware to the system, and now the signal is well under the signal of the contaminant. Before, the signal from the noise was over 300, and now it is 49. The signal from the metal stayed at around 2 to 300. The system can now operate in the presence of the noise.